Hi, in this video we are going to discuss some problem for week 1, and these problems should be very helpful for your assignments for week 1, including the MyMathLab homework assignments and the quiz. The first questions: find the polynomial functions with the roots of 0, -1, 3, and 3 has the degree of 2. So we know that for any function polynomial, we can have the general form, which is a0. A0 can be any constant. We call this is a0. Some textbook they call it a or b. So depending on the textbook, but we just know that this is the constant in the front of the polynomial. Now we have one root here, two root, three roots, right? So we know that x minus r1, this is root 1, the first root, and then we have the second root, r2, and then we have the last root, which is r3. If we have more roots, then we just multiply the factor, keep going to the right, multiplying them together. Now we know that the first root is 0, so r1 is 0, so minus 0. The next one is r2, the second root is -1, so that should be x minus r2 now is -1. So don't forget that we already have the minus in the front, so double minus here. And then the last one, when r3 is 3, so x minus 3. However, this last factor, the roots with the solution 3, has the degree of 2, so make sure that you have the power of 2 for the last factor, and then we can clean them off, simplify the factors here. So a0 still there, x minus 0, which is x, minus become plus, and then minus 3 square. Or in general, you can have the polynomial as a0 x plus 1, and then x minus 3 square, and this should be your polynomial. You can write a0 as a, doesn't matter, we know that it's just a constant of the polynomial. The next questions: analyze the graph of the polynomial function given here. Okay, determine the end behavior of the graph. Now before we do anything, make sure that we know that the function is the polynomial function is written in the standard form, which means go back to the first equations: x minus root 1, x minus root 2, and x minus root 3, and so on. Now I can rewrite this one, right? Very simple. I can rewrite it. X subtract nothing, so the first one does mean x subtract 0, because subtract 0 you get back x. So we know that the first factor means that we have the root of 0. And then the second one, because this is not a minus, right? We need the minus for the roots, so we can make the plus into the minus by using the double minus, minus 4 to the third power. And then these two, normally you want the variable x to go first before the 3. In this case, you can pull out a minus, and then you can make the minus go first, the x go first, and then subtract 3. Why? Because when I make the distribution of the minus inside, I get minus x, and then plus 3, which is plus 3 and minus x, again the same thing. So I just pull out the minus in the front, and then again I still have the power of 4. And then the last one, I need to make this 3 minus, so x minus of -7 to the second power. Now let's just clean this again one more time. X subtract 0, this is the function, x minus 4 to the third power. Now because this is the -1 to the fourth power, -1 to the even power, so it will become a +1 again. So it doesn't matter for the minus to be here, because the minus to the even power becomes a positive 1 again. So I can just ignore that. so minus 3 to the 4th power, and then x minus 7 to the square. Okay, so now they ask you to determine the end behaviors of the graph of the function. Now, before you can know the end behavior, we have to figure out what is the power function, because the power function is the function we are using to determine the end behavior. Let me show you something here. Go back to, okay, for the end behavior, we are looking for a leading terms coefficient of the polynomial. Now, for the even power of the leading terms, even power, then you either have open up on the two on the two left and the right sides, or going down on the two left and the right side, depending on the coefficient in the front. If the coefficient here, the number here is bigger than 0, then they both go up on the two end behaviors. If the coefficient an is less than 0, then they both go down. Okay, this is for the even power of the leading terms. Now for the odd power, I have the two cases. Again, it has to be dependent on the coefficient an. If you have a positive an, then you go up to the right, go down to the left. If you have a negative an, then you go up to the left, go down to the right. So the best way to figure out the end behavior is by finding the leading term or finding the power function. How do I find a power function? Okay, so we take the leading term for each of the factor. So this is x, so I take out the x to the first power, right? Nothing, which means the first power. And then for the second term, second factor, again, I have the x, right? I have the x, and then don't forget the power of 3. I just take the leading term for the second factor. The next one would be the x, right? The x of the 4th power. But don't forget the minus here, right? Because we still have the minus in front of the x term, so don't forget that we have the minus of the x here. The minus still stay in the front, so minus x, and then we take the leading terms to the power of 4, and then, but doesn't matter, right? Minus to the 4th power still give you back the +1, or you can just take the directly x to the 4th power from here. And then here the last one is x. Take the leading term, and take the power of 2. Okay, so let's see what do we get here. X, they all have the base x. We add the power, 3 plus 1, 4, 4 plus 4 is 8, plus 2 is 10. So the power function in this case is x to the 10th power, or 1 times x to the 10th power, because there's nothing here, that means there should be number 1 here. Now we know that the power is n. This is even power, right? Even does mean we have the two cases, either the 2n go up or the 2n is going down, the end behaviors. Which one do I pick here? It will depend on number 1 in front. This is for the case when an is bigger than 0, we go up on the both end behaviors. Or if an is less than 0, then we go down on the 2 end behaviors. In this case, number 1 is positive, bigger than 0, so we know that the end behavior is going up. It's going up on the two sides. This is y, this is x. So as the x approaching to as x is approaching to infinity, the function f of x is going up. is approaching to infinity. Now, as x is approaching to minus infinity the other way, then the function f of x is also approaching to infinity, going up. So this is the end behavior of the function. And then the next question is, what is the maximum number of the turning points? Now let me show you what's the turning point. The turning point is the point that is changing from decreasing to increasing, or increasing to decreasing, or decreasing to increasing. So this point, and this point is the turning point of any polynomial. Now, we don't know exactly where the function is increasing, where the function is decreasing or increasing, but there is a rule here. We know that this function has the power function of x to the 10 power, x to the 10 power. Therefore, the maximum number of the turning point is n plus 1. This is the rule. So 10 subtract 1, which is 9. So we look for the power function, right? Power function. And then we look for the degree, and in this case 10. And then what about that degree? We subtract 1, and that is the maximum number of the possible turning points, which is the maximum possible turning point that you can have for any for this function. So in this case, 10 subtract 1 is 9. So there's the maximum of 9 turning points. It can be 9, it can be 7, it can be 6, but no more, no bigger than 9. So anything from 9 and below turning points. Now, how do I find the x and the y intercept? The x-intercept is basically the root or the solution of the equation, the polynomial, right? Because when you have the solutions, for example, this one, right? The solution is when the function is crossing or touching the x-axis, which is the x-intercept. So how do I find all the x-intercept in this case? I know that this is the root 0, right? Minus 4, the second root. This is 3. Don't forget we have to put the minus in front, and then minus 7. So 0 minus 4, 3 minus 7. 0 minus 4, 3, and minus 7. These are the 4 x-intercept of the this polynomial. Okay, and how do I find the y-intercept? The y-intercept happens on the y-axis when the x value is equal to 0. So to find the y-intercept, I plug in 0 for anywhere I see x, right? So when my x is 0, I have 0 here, 0 plus 4 to the third power, 3 minus 0 to the fourth power, 0 to 0 plus 7 to the square. And I don't care about what happened here, because I know that anything multiplied by 0 results in 0. So this should be the y-intercept of the polynomial, because this is the value when the x is equal to 0. So x-intercept are these 4, y-intercept is 0. And you can also write the x-intercept in the order pair. 0, that means 0, 0. Minus 4, that means minus 4 and then 0. 3, that means 3 and then 0. Minus 7, that means minus 7 and 0. And then the y-intercept 0, that equal to 0, 0. And then the next question, determine the zeros of the functions and their multiplicity, right? The zero of the function is the same thing as the x-intercept, right? So the zero of the function just the value of the x-intercept. So x1 equal 0, x2 equal -4, the 0, x3 equal 3, and x4 equal -7. Okay, and then their multiplicity, which is the power. I know that, go back to this one, for the 0, the root 0, I don't see any power. That means that's number 1. So for the 0, the multiplicity is 1. For the -4, we have the power of 3. So the multiplicity is 3. For 3, the power is 4. So the multiplicity should be 4. And for -7, the power is 2. So the multiplicity should be 2. Okay, so this is the multiplicity of the root. This is the root. Now, use this information to determine whether the graph touches or crosses the x-axis at each intercept. Now, touches mean at this point the function is touching, and crossing mean at this point is going to the x-intercept. So touching, crossing. Okay, there's a rule here. If you have an even multiplicity, then you are touching. This is for even multiplicity, then you are touching the x-axis. If you have the odd power, then you will crossing to the x-axis. So this is 1 is the odd, right? So crosses. 3 is also the odd value, so crosses. 4 is even, so touch it. 2 is even, so also touches. Okay, and the roots is the same thing as the x-intercept. Now determine the domain and the range for the function. Again, any polynomial, you can go anywhere on the x-axis, so the domain should be -infinity up to infinity, no restrictions. For the range, again, for any polynomial, the range can be anything on the y-axis, so also -infinity up to +infinity. The last part is determining the intervals on which the function is increasing or decreasing. Okay, so we know that there is the 0, the roots are 0, -4, 3, and -7. Let's plot it. 0, -4, -3, no, -4 right here, and then 3 is right here, and then the last one is -7. So all the way to the left here, something like that. Okay. Now let's pick a value. Okay, so let's make the boundary. Let's make the boundary, and now we are doing some testing. We know that go back to the function x plus 4 to the third power. So the function x plus 4 to the third power. 3 minus x to the 4th power. 3 minus x to the 4th power. And x plus 7 to the second power. Now, let me pick a value on the left side, -7. Say -8. Okay, -8. Now, -8 for x. So I plug in -8 to this function. Okay, let's see if I get something positive or something negative. So -8 for x. -8 go to here. That means I have a minus, right? -8 plus 4 give me -4. -4 is a minus value, so minus to the odd power still give me a minus value. 3 minus of minus 8, so double minus become plus, so a plus to the 4th power, that should be plus. Minus 8 plus 7, that's minus 1. Minus 1 square is a plus. So we know that we multiply them together, right? Multiply them together. So now I'm also multiply that together. Minus multiplied by minus give me plus, and plus multiply by plus, multiply by plus. At the end, I get something with a plus value. Okay, so should be something up here, right? Should be something up here. The plus, because this is a 0 level. This is 0. So up here is something plus. Now between minus 7 and minus 4, pick a value, say minus 5, right? Between that. Now minus 5, this is for x. So minus 5, I plug into x, I have minus. Minus 5 plus 4, minus 1. Minus 1 to the 3rd power, still a minus. Minus 3 minus minus 5, that becomes plus 8. Plus 8 to the 4th power is plus. Minus 5 plus 7, that plus 2 square is the plus. So minus minus become plus, 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 plus. At the end, you should end up with a plus. Again, you should have a plus. And we know that at 7 minus 7, you are touching the ref. That means you go like this, touching. You cannot go down here. That's why you have to turn, you make a turning point. So there is a turning point right here. Turn up here, right? Something like that. Now, I don't even need to test this one if I know where the function is crossing or touching. As the next one is minus 4. Minus 4, I should be crossing. That means in order for this curve to crossing as minus 4, somehow it has to go down, so it's crossing to minus 4, right? Because you want to go down again to crossing. Yes. And then from 0 is crossing again. So in order for this one to crossing this one, you have to go up again to crossing. And for 3, you are touching. That means from here you go down and then you are touching, go up again. Okay, so we can see that from minus infinity up to minus 7, the function is decreasing, and then from minus 7 to minus 4, the function is increasing, and then it has to decreasing in order to cross it to minus 4, and then from minus 4 to 0 it's decreasing, and then somehow it has to increasing again so that it can cross through the 0 and going up and keep increasing, and then it has to decreasing to minus 3, and then from here we are touching, so we have to increase it again after 3 up to infinity. So that's how the graph in general looks like. The next step, the next question, find the real solutions to the equations. Okay, so how do I find the solution? This is to the 4th power, so it's difficult to find the solutions. It is not a second-degree polynomial, so you cannot really use the quadratic formula. Now there's something called the rational zero theorem, right? So let me get to that one here. The rational zero theorem. So for this one, we have a given polynomial. A0 is the last constant value. An is the constant of the leading coefficient. So basically we are saying that the factor of A0 divided by the factor of an. These are the possible rational zeros of the given polynomial. So what does that mean? Okay, so I know that I have no idea how to find the solution to this 4-degree polynomial, but I can use the rational zero theorem to find a list of possible values that I can do the testing to see which one is the solution to the polynomial. Now, this is the leading coefficient. So an is a number in front of the leading coefficient. The last value, the constant, is a0 minus 6. So we know that this is the list of the possible zero. Possible means one of them or two of them or three of them should be the solution to the roots to this polynomial, but not all of them, right? The possible zero. Okay, so we know that we take the ratio, the factor of minus 6. So minus 6 had a factor of plus or minus 1, plus or minus 2, because 6 divided by 1 by 2, plus or minus 3, plus or minus 6, right? So that is the list on the top, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Now at the bottom, we take the factor of 2. So of 2 and we can have plus or minus 1 or plus or minus 2. These are the only two factors for an. So plus or minus 1, plus or minus 2. Now this is just the ratio, but we need to find the actual value. So take 1 plus or minus 1 divided by 1, so plus or minus 1. Plus or minus 1 divided by plus or minus 2, so plus or minus 1/2. And then take the next one, plus or minus 2 divided by 1. Plus or minus 2 divided by plus or minus 2. The same thing with plus or minus 1, so we don't have to rewrite it. Now, plus or minus 3 divided by 1, so that is plus or minus 3. And then plus or minus 3 divided by 2, that is plus or minus 3/2. And then 6 divided by 1, that is plus or minus 6. And then 6 divided by 2, that is 3, which is the same thing as this guy, so I don't have to rewrite it, right? So in general, we know that the list should be 1 minus 1 plus 1/2 minus 1/2 plus 2 minus 2 plus 3 minus 3 plus 3/2 minus 3/2 6 and minus 6. Okay, so this is the function f of x. Now we have 1 2 3 4 5 6 7 8 9 10 11 12 possible values that could be the real solutions to this equation. Now we have to take each of them, plug in for x, and see which ones give you the value of 0, because you are looking for the 0 of the solutions. 0 is the root. Now this is a long testing, so I am not going to show you all the work. I have already done that, so I'll show you here. I plug in 1 to here, right? 1 to here. I figure out that it's give me 12. So that is not a 0, right? I plug in minus 1 again to here. It's give me minus 18, still not. I keep going on the list, right? The list is all of these numbers. So I plug in all of them, and then I found out that only this guy, minus 3 and 1/2, that give me the 0 to the polynomial. So minus 3 and 1/2 are the only two from the list that give me the 0. So they are the solution to the equation. Okay, so minus 3 and 1/2 from what I did here. minus 3 and 1/2. Right, minus 3 and 1/2. Okay, we know that this one is the 4-degree polynomial. That means we are expecting to get 4 solutions, 4 roots, 4 answers. But now, from the possible zeros, we only obtain 2 of them. So where are the other 2? Okay, so we have to use something else called a synthetic divisions to figure out the other 2 solutions, the 2 roots. Now, let me show you the way to do that. We first graph the coefficient of the polynomial. So this is 2. So I line them up, right? And then the next one, this is 4. Make sure that they are in the descending power from larger to smaller. 4, 3, 2, 1, and then 0. Now we take the coefficient of that. 2, next one is 5, and next one is 1, and then 10, and then number 6. Okay. Now we know that number 3 is one of the 0. So now I take number 3. I do the synthetic divisions. How do I do that? The rule is that you bring down the first value, 2. Okay, always bring down the first value. Then we take this guy, the 0 we found, we multiply with 2. Minus 3 times 2, minus 6. Then we add them. Minus 6 add to 5, give me minus 1. And then now again, minus 3 times minus 1, give me plus 3. You add them, you get 4. Minus 3 times 4, minus 12. You add them, you get minus 2. Minus 3 times minus 2, that is minus plus 6. Now you add plus 6 and minus 6, you get 0. And we expect to get a 0 for the end, which is no remainder for these divisions. Because we know that we have the 2 answers, 2 roots from the list, let's keep going 1 more divisions. Okay, so we finished the one with minus 3. So we do another one for 1/2 in order to find the factors for the remaining 2 roots. So 1/2. Again, I always bring down the first number. Okay, so minus 1/2 times 2, I get 1. I add these 2 numbers, I get 0. Okay, now minus 1/2 times 0, I get 0. I add these 2 numbers, I get 4. Minus 1/2, sorry, 1/2 times 4, that give me 2. 2 and minus 2 add, give me 0. And we are done. Okay, so after you do the synthetic divisions, we are ready to write the polynomial from this coefficients. Now we ignore the last value. If this is 0, we ignore that. So we count from here, right? So because we have only 3 values, right? 3 values. So this one should be the constant terms. The next one is a linear, constant, linear, and then this one is the quadratic. Okay, so now we can write the factor for these 3. The constant 4, that is 4. The linear 0, which means nothing. Right? I don't add anything because 0 is 0. 0 multiplied by anything is 0. 2 go with the quadratic terms, so that means 2x to the square. 2, these numbers stand in front of the variables, or these numbers are just the coefficients. So 2 go to 2, quadratic means x squared. This is the constant, so just number 4. So this is one of the factor you can get after you do the divisions. And we know that because we found out that these 2 are the solutions, the roots of the polynomial, then I can write this way, f of x. This is the roots, right? So x minus 1/2, because we know that in general x subtract the roots, this number is the root, and then x minus the other root is minus 3. Okay, and these are the two factors from the roots, and then we got the last factor from the other two roots after we do the divisions. So the last factor is 2x squared plus 4. We attach that to here. So x squared plus 4. 2x squared plus 4. Sorry, let me erase that. Actually, let me move it here. Move it to the left. Okay, so f of x is equal to x minus 1/2, x minus 3, and then x 2x squared plus 4. Okay, and this is the factor form of the polynomial, and that should be equal to 0. So equal to 0. Okay, now these two, we know that they are already the 0. The last one is we need to figure out the last factor. What is the 0 of that? Because this one all equal to 0, that means each factor should be equal to 0, because we know this one is 1/2, this one is 3 already, so we don't need to care about the roots for these two factors. The last one, we set it equal to 0. So move the 4 to the left side, divide by 2, minus 2. So take the square root, plus or minus the radical of minus 2. Now this is the imaginary numbers, because we have the minus under the square root, and the question only asks you to find the real solutions. So in fact, these two are the answer. We don't need to care about this one, because this is not a real solution. But if you want to find the complex solutions, well, just finish this one here. We can bring the square root of minus 1 to be I, and the square root of 2. So these two are the two complex solutions to this polynomial, in addition to these two real solutions. Okay, next question. A polynomial has a real coefficient. The degree is 4. The two of the zeros are I, and the other one is 5 plus I. This is the complex solutions. Find the remaining zeros. We know that this is the degree 4, so we are expecting to get 4 different solutions. These two are only 2 solutions, so we need 2 more. We know that if I get the one complex solutions, then the conjugate of that is also the solutions. Now the I here mean the plus I, so the conjugate of plus I is minus I, so minus I is another solution. The conjugate of this one, I'm changing the plus to minus to find the conjugate of that, so I keep the other two the same thing, plus to minus. So this is another solution. This is another solution to this polynomial. Next question, solve the inequality. Okay, so solving inequality, that means you are looking for the interval in which this inequality is true, right? So before we have to set each of the factor equal to 0. Set it equal to 0 to find the boundaries. And then next one, x minus 4 equal to 0, and then x plus 1 equal to 0. So solve for x minus 2, 4, and minus 1. So I know that minus 1 is here, minus 2 maybe here, and then 4 maybe here. So I know that these 3 values make the boundaries for this inequality. Okay, now let's see. We are looking for the value that is bigger than 0. Okay, bigger than 0, so positive. Now on the left side of minus 2, let's see we pick minus 3 for the testing. So minus 3 go here, go to x minus 3 plus 2, that is minus 1, so minus. Minus 3 minus 4, that is minus 7, so still minus, right? Minus 3 plus 1, that is minus 2, so still minus. So we see that minus minus become plus, plus and minus, plus and minus still a minus. So this is a minus, which is not bigger than 0. So the answer is no. Between minus 2 and minus 1, let's see, I pick minus 1/2. No, minus 1.5. This is not true. Between minus 1 and 2, I pick minus 1.5. Just for testing. So minus 1.5 go to here. 2 minus 1.5, that is the 0.5, so that's plus. Minus 1.5 minus 4, that is a minus. And then minus 1.5 plus 1, that is 0 minus 0.5, also a minus. So we see that double minus become plus and plus and plus. At the end, give me the plus, which is positive. So the answer is yes. Now between minus 1 and 4, just for easy, pick a 0. 0 plus 2, that is plus. 0 minus 4, that is minus. 0 plus 1, that is a plus. We have plus minus become minus. Minus with the plus become minus. So this is negative, which is not bigger than 0. So the answer is no. And then pick a value to the right of 4. Let's see, 5. 5 plus 2 is plus. 5 minus 4 is also plus. And 5 plus 1 is also plus. Plus, plus, plus. At the end, we multiply all the plus together. You get a plus value, which is bigger than 0. So the answer is yes. Okay, so the one that makes this inequality true is when the answer is bigger than 0, which is this interval and this interval. So we do not include minus 2 and minus 1 because we don't have the equal sign here. So the interval should be minus 2 minus 1 union with 4 and all the way to the right. So this is the solution to this inequality. Okay, solving the inequality. This is a rational inequality. Again, we are looking for something that makes this inequality to be true, which is less than or equal to 0. Now, this is a rational inequality, so there are two things to consider here. The first thing is when you want to make the numerator to be 0. So first thing, again, we need to find the boundaries for the inequality. So how do I find the boundaries? We set the numerator to be 0, and we also set the denominator to be undefined or to be 0, because you cannot divide by 0. Anytime you are dividing by 0, it's undefined. So anytime the denominator equal to 0, that makes it undefined. Okay, so we have to find the value of x that make the numerator to be 0 and the value of x that make the denominator to be also 0. Okay, so x squared minus 9 set it equal to 0. This is the difference of the square, x plus 3, x minus 3 equal to 0. So that gives you x equal minus 3 and x equal 3 are the solution to that equation. And then we also set the bottom to be 0. So I factor out x squared. I get 1 minus 5x equals 0. And set x squared equal to 0, that means x equals 0. And 1 minus 5x equals 0, that means x equals 1/5. So we have 1, 2, 3, 4. Now, I label them minus 3, 3. I put a 0 because these are the two zeros of the function. And then for 0 and 1/5, I put a UD. That means at these two values, you know that the function is undefined. Okay. Now, so basically, we know that we have the this boundaries, right, for the testing. Now, we are looking something that makes the function to be less than 0. For some reason, the format is wrong here, but yeah, it's less than 0. We just saw that less than or equal to 0. This one, right? We are looking for negative or 0 of this function. Okay, so I'm not gonna go over all the process like the last problem, but we know that b on the left side minus 3. Let's pick a value. Let's say minus 4. So take minus 4, go here, here, here. I figure out that it's give me a plus. Right, it's plus a positive value. Between minus 3 and 0, pick a value, throw them in here, and do the testing. I get minus. Between 0 and 5, do some testing. 1/5 and 3, pick another value, do the testing here. And then from 3 all the way to the right, pick a value to the right of 3, maybe 4. And throw the 4 in here, and then I get a minus. So we are looking for negative or 0. Negative or 0. That means this is negative, so the answer is yes here, yes here, and then yes here. So how do I write the answer in the interval notation? I know that I'm also looking for the 0. And from 0, in this yes interval, 0 to undefined, so minus 3 go to 0, minus 3, 0. The reason I use a bracket on the minus 3 because minus 3 includes a 0, which is what I'm looking for. Right, so I use a bracket. I want to include that minus 3. For the 0 for undefined, I have to use a parenthesis. Right? You cannot include a 0 because that makes your function to be undefined. And then the union with the next one. Again, from 0 up to 1/5. Again, these are the two undefined, so we cannot use a bracket. Brackets mean including that point, but you don't want to include those 2 points because that makes your function to be undefined. So you have to use the open parenthesis. And then the last one is from 3 up to the right, so 3 from infinity. And we want also to include a 0, right? Because this is negative or less than 0. So we have to include the value of 3, which makes the function to be 0. So these are the solutions to this inequality. There's something wrong here, but this is the function. Number 7. Okay, there's something wrong with the format. Let me fix that for quick. Okay, this second question. Find the domain of this rational expression of function, and then find the vertical, horizontal, or oblique asymptotes, if any. Okay, so before you can find any of the vertical, horizontal asymptotes, the best way for any rational functions, polynomial functions, we must write them, rewrite them in the factor forms. Okay, so that factor at the top, I know that I can factor out the 10, x minus 8. At the bottom, grouping, factor by grouping. Between the first two, I can pull out the x squared. I have x minus 4. Between the last two, I can pull out the 16, minus 16. So I have x, and then I have minus 4. Now we see that there's another similar factor, so I can pull out the x minus 4 one more time. X minus 4 to the front. When I pull out that to the front, I get x squared. Right? I pull out x minus 4, I get minus 16. And then x squared minus 16, I can further rewrite this one, x minus 4. X squared minus 16 is x squared minus 4 squared. This is the difference of the 2 squares, so that's become x minus 4 and x plus 4. And we can combine x minus 4 together so that I can get x minus 4 to the second power and then x plus 4. Okay, so we are good for the factor forms. Now, to find a vertical asymptote, you are looking for the value that make your denominator to be 0, because the vertical asymptote happens when the function is undefined, and when your function is undefined, that means you are dividing by 0, and dividing by 0 that means the denominator is 0. Okay, so I set up the denominator equal to 0 to find the vertical asymptotes. X plus 4 equal to 0. And then you can set that each of these two factors equal to 0, right? X minus 4 square equal to 0 or x plus 4 equal to 0. And the same thing as x plus minus 4 equal to 0 or minus 4 on both sides, so x equal minus 4. You get 1 here, and then you add 4 on both sides, you get x equal plus 4. Okay, so minus 4 and plus 4, these are the two vertical asymptotes for your rational function here. Okay, now how do I find the horizontal asymptotes? That's the next question. Horizontal asymptotes. Okay, so there's a few rules here to find the horizontal asymptotes. Now, in order to find the horizontal asymptotes, we compare the leading term from the numerator and the leading term from the denominator, right? So here, the leading term for the top, the numerator, is 10x. The leading term is the term with the highest power. And the leading term for the denominator is x to the third power. So we compare them. And we know that from the textbook, there are a few rules. There's a few rules about the horizontal asymptotes. Okay, so for now, let me call the okay, there are three cases. The first case, if the degree on the top is less than the bottom of the leading terms, then the horizontal asymptote is the x-axis, y equals 0. Okay. The second case, if the degree on the top x is bigger than the bottom, then there's no horizontal asymptotes. Okay. Now, if the last case, if the degree on the top is equal to the degree of the bottom, or the degree of the leading term of the numerator is equal to the degree of the denominator, then the horizontal asymptote is equal to the ratio between the two coefficients, the ratio. Okay, in this case, we see that the degree on the top is less than the bottom. So 0, y equals 0, or the x-axis is your horizontal asymptotes. Now, unless we don't have the horizontal asymptotes, then we might have the Afflicts asymptotes. And the Afflicts asymptote is when the degree on the top is one more higher than the degree of the bottom, comparing the two leading terms. In this case, the degree on the top is not larger than the degree at the bottom. We need the condition, the requirement to be the degree of the top number, the top term, is one more higher than the degree of the leading term of the bottom, in order for you to get the Afflicts asymptotes. In this case, it's not, so we don't have that. But in the next question, you see. Now, find the Afflicts asymptotes, if any, in the below rational function. We know that the degree on the top is 2. The degree of the bottom is 1. 2 and 1. 2 is larger than 1 in 1 unit, 1 degree. So we should have the Afflicts asymptotes. And how do I do that? We have to do the long divisions. Let's do the long division. X squared plus 2x minus 3, and then x plus 1. Okay, so how do I do the long division? I take the first term x squared, I divide by the first term x, I get x. Okay, so I put x here. Now I take x, multiply by x, give me x squared. X multiply by 1, give me 1x. Now let's do the subtraction. X squared subtract x squared, 0. 2x subtract 1x, give me plus x, right? 2 subtract 1 is plus 1. And now I carried out the next term, minus 3. Okay, so then the next step is, again, I take this first term, x, I divide by this term here, which is x, so it's give me 1. So the next one is 1. And now I take 1, I multiply to x, give me x. 1 multiplied by 1, give me plus 1. And then I do the subtraction. This is a long division problem. X subtract x, 0. Minus 3 minus 1, give me minus 4. Because we don't end up with a 0, we end up with minus 4. So minus 4 is the remainder. And the Afflicts Asymptotes is the result, the quotient of this long divisions, which is x plus 1. So y equal x plus 1 is the Afflicts Asymptotes. Okay, so make sure that the degree on the top is 1 more degree higher than the degree of the bottom. Okay, so that is the end of the week 1 discussion problems, and I hope that these questions, these problems will help you to work on your assignments on MyMathLab, and also on the week 1 discussions as well as the quiz on MyMathLab. Okay, thanks for